Hello, this is Brian Sam-Bodden, and I am here to introduce you to Redis as your primary database. I will be repeating this in the next few minutes, and I will just wait a good 60 seconds for everybody to join. Okay, well, hello. Welcome to From SQL to NoSQL. My name is Brian Sam-Bodden, and today we're going to be talking about how to use Redis as your primary database, specifically in Java and more specifically in Spring. So I am bsb@redis.com if you want to reach me. You can also find me on Twitter at bsbodden for the time being. And my GitHub username is bsbodden. I am a senior developer advocate, and I'm also a Java champion. All right, so let's get into it. The basic premise of this talk is that with a NoSQL database like Redis, when you add powerful searching capabilities, you can approximate the expressiveness of SQL. And of course, there's many other features that a NoSQL database will give you an advantage over SQL. So for those of you that are not familiar with Redis, let me quickly introduce you to Redis. Redis, it's the remote dictionary server. That is the Redis acronym. It takes from those 5 letters in that phrase. In Redis, it's a in-memory first, optionally persistent database. And I say in-memory first because the line between memory and disk, it's getting blurry and blurrier with time. And if you think about it, everything that is important to your database, into your database operations happens in memory, whether that database it's an in-disk first or an in-memory first. In memory first, it just means that we are there when you need us and ready to react at a speed that disk-bound databases are not. So in Redis, traditionally, people recognize Redis as a key value pair database. And what people typically don't know is that in Redis, the key value, the value part, can be a whole universe of things. For example, the most common data type for the key value is strings. Everybody knows how to work with strings. It is the most used data type when it comes to caching. You take, for example, an HTML page snippet and throw it into a key value where the value is a string, and then you basically get it back maybe by the URL of the page. But that is only the tip of the iceberg. You have bitmaps, you have bit fields, you have hashes. Hashes being one of the workhorses of the Redis community. Hashes map really well to objects. So pretty much every language that uses Redis, every programming language library will have a language representation of an object that basically maps to a hash. We also have lists, sets, sorted sets, which are used extensively for anything from leaderboards to anything that requires basically a set where there's a value bound to the set and you can do fast operations on that set in order. We also provide geospatial indexes and a whole collection of probabilistic data structures. One that comes built in with open source Redis, it's hyperlog, but there's a few more. And also Redis provides not only PubSub, so most people are familiar with Redis as a PubSub provider, but Redis also has a streams provider. So if you want to do something like Kafka Lite with Redis, Redis provides a streams facility that can also interact with some of the other data types. So that is the core open source Redis, basically a key value database that provides the ability to store the values in a lot of different formats and manipulate those formats. But there is more. In this session, I'm going to focus in two of the capabilities that we have introduced in recent years. And one of them is the ability for the value and the key value to be a JSON document. JSON being one of the most used formats for anything from microservices to document management. And again, the premise of the talk is that when you marry JSON documents and hashes to a powerful search engine that can search over those documents or hashes, you have a very powerful solution that can rival the flexibility of SQL databases. It's certainly way faster than that. Imagine that when your cache is the database and the database is your cache, things are pretty fast to begin with. So Redis provides a full text search engine. And that full text search engine allows you to create better secondary indexes. So for example, in most NoSQL databases, some data structure will be used to provide a secondary index for a data structure. And with Redis search capability, you don't have to do that manually anymore. You can do the same thing that you would do with a relational database or with a powerful search engine like Elastic, for example. And you create indexes. Those indexes are maintained automatically by Redis. So you don't have to be programmatically manipulating data structures to create indexes or maintain an index for some collection in your NoSQL database. We have geo-aware indexes too, so you can have geographical data in there and search in index and search over those values. And we also have an aggregation pipeline that we're going to be looking at today, which allows you to basically do analytical queries in things like summing and averaging and collecting values from different parts of your data pipeline. So Redis definitely loves Spring, and we at Redis are sponsored a project called Spring Redis Own, which is an extension to Spring Data Redis. So Redis Own Spring allows you to tap into all the power of the features of Redis in the context of Spring. So let me tell you a little bit about Redis Own. Redis Own, again, it's a multi-model object mapping and querying. It's part of one of the projects that extends the Spring data interfaces. And it actually extends Spring Data Redis. So if you have used Spring Data Redis to work with OSS Redis, Redis Own Spring extends that project to add extra capabilities. So Redis Own Spring extends Spring Data Redis, and we use under the cover the Java driver Redis, which we are also the maintainers of. All right, so let me give you a quick overview of what we're going to be seeing in the code today. So the basic premise of using JSON with searching capabilities in Spring with Redis is that you annotate objects with a document annotation. So in this example on the screen, we have a class called fictional character. It's annotated with the document annotation. And inside of it, you see some of the familiar Spring Data annotations, for example, ID in this case, being the only one. The two other annotations, indexed and searchable, are part of Redis Own Spring. And they allow you to automatically create an index, a search engine index for your entity. In this case, we have index will look at the data type of the specific field in the object. So for example, the string actor first it's annotated with index. Since it is a string, that would be turned into a tag schema field in Redis search. Similarly, the same annotation is being used with an integer. That would be a numeric type in Redis, in the Redis search engine. And searchable, it's a specific one that is used with strings, and searchable allows you to map that as a search engine field that provides full text search capability. So you can do basically fuzzy searching, prefixes, suffixes, all the fun stuff that you can do with a full text search engine. In, for example, down below, you see that the point class, the Spring point class, it's also indexed. That will create a geo-index in the index in Redis. So it's a pretty versatile pair of annotations, searchable and index. And then for your documents, you basically annotate them with document. The same capabilities with a little less power are available for hashes. Obviously, hashes are not as flexible as JSON documents, being basically a single level, the equivalent of a single level JSON documents. So the Redis hash annotation provides the same functionality. So you could have the same object, fictional character here, but annotated with the Redis hash annotation, and you would basically have it now persisted as a hash in Redis, just like Spring Data Redis provides, but all the secondary indexes and all the powerful searching, it's available to that object too. All right, in Spring Data, we have the notion of repositories. Repositories are kind of like DAOs, but at the entity level in data access objects. So a typical example would be the CRUD repository in Spring, and then the pageable and searchable, pageable and repository that extends that. So there's two interfaces in there. We add two extra interfaces that represent repositories. One is the Redis document repository, and the other one is the Redis enhanced repository, which is for hashes. And obviously the Redis document repository, it's for entities annotated with the document annotation. So in here is an example of a repository, and some of the type of queries that you should expect are available from Redis on Spring. So in here we have, for example, find an actor by an H in between some values. So you can do range numeric searches. You can do searches by multiple fields in an object. So in this case, I'm looking for an actor by first name and last name, by locations. You can do things like, for example, by prefixing a search method with search, you're searching by quotes. So in this case, we have a search by quote and pass a free form text. We have also searches in nested indexed objects. So for example, in here, we have a find by actor address underscore city. That means that the object the object has an address field, and that field itself has a city field. So this allows us to traverse into that city of value object to do the search. You can set find something by a set of values. So for example, in here we have a field called skills on the find by skills method that would basically take a set of values to basically be matched against that collection of skills. So that could be a JSON array or an array store in a hash. And there's a lot of modifiers that Spring Data provides, and then we support them. So for example, you can say find by skills containing all, and then pass that same set of skills. The first one, without the containing all, will do an OR of the values. So if any of the values are available in that skills set, then there will be a match. And the second one has to match all the values. All right, so now let's go to the code. So the demo that we're going to do today, it's based, so I wanted to find a schema that was representative of relational databases, just to see how hard it would be to basically turn that into a collection of entities in a NoSQL database like Redis. So for that, I picked a data set called Sakila. In the Sakila data set, it's a super normalized, like, fifth normal form schema that it models a DVD rental store. And it's distributed by MySQL, and it's been around for ages. And it's one of the flagship examples that it's always used to basically teach relational database concepts in querying, store procedures, store functions, and things of that sort. So I took that original schema in MySQL and created a translation layer to turn that into Redis JSON documents. So if you're interested in looking at this Sakila sample database, you can basically get it from the MySQL website, and the URL is on that slide, and I'll be providing the slides after the webinar. So here is a little view of what the schema looks like for this. And you can see that there's a lot of arrows pointing from one place to the other, meaning that it's likely very denormalized. So things have associations to other things all over the place in this schema. So the central entity in here, I would say it's the core heart of the business, of this fictitious business, would be the rental table. The rental table basically keeps track of the DVDs that have been rented by this fictitious store. And then you can see that the DVDs are represented as the film, and a film has categories, has actors. You can see there's connection tables. For example, film category connects a film in a category entity. The film actor connects a film to an actor. So it's a pretty denormalized database. So we're going to see how we can handle that in mapping it to a Spring Boot application using Redis on Spring and using Redis Stack as the foundational database. So just to give you a preview, I did have to make some changes. So I had to make some changes in a few places to be able to run a specific aggregation I wanted to run. So the typical things that happens when you go from SQL to NoSQL, it's that you, rather than normalize more, you denormalize certain things. So you flatten things, you combine things, and sometimes you actually duplicate data. It's different vision of the world between a relational database and a NoSQL database. The relational database want to be, it tends to be as normalized as possible, but you will find that in most places, you find tables that are heavily denormalized for performance. So the relational world ends up doing what we do just because of performance reasons sometimes, or sometimes complexity. Sometimes there's too many joins, and creating a query that joins across the universe, it's just too complicated. And sometimes they create a view or a table that flattens or aggregates all those values. So the NoSQL premise is that we're giving you that operational data already in the form that it needs to be to run the business. So let's jump to the IDE. And I am using IntelliJ, and I am going to, so first I created a project using Spring Initializer. I downloaded that project, and I use that as the seed. So I'm using Spring Boot 3.10. This currently it's 3.11. I'm creating a jar, and it's a Java 17 project. And I have a little facility that I use to basically play the commits in a repository like there are slides in the presentation. So that's what I'm going to be doing throughout the session today. So you can see here that I have a project. It's called Sakila Redis, and you can see it's empty right now. I only have a README in there. So I put a README that basically describes what was done to the project. you can see that the conversion that I did, actually, I loaded the data, the MySQL schema into MySQL. I mapped it to JPA entities. So I generated code for Spring Boot to create JPA entities. I loaded the data into those entities. I also created mirror objects that were annotated with the Redis annotations. And then I created basically a generated method between the two objects that could basically map one to the other. And then I saved the objects to their Redis destination. Then I created a dump of that database that was loaded initially, and that became a JSON file that if you pull this repository, you'll be able to load that into Redis using the Riot tool. And there's a tool that we distribute. It's available pretty much through every channel available. You can brew install Riot if you're on a Mac, or there's installers available, and that would allow you to basically slurp that JSON data into Redis and be ready to go. So the first thing I'm going to do is load the Spring starter skeleton. So notice in here that my tree view changed, and that is because now I have some data, some code to show you. So this is basically the empty skeleton application. So let's take a look quickly to see what we're working with. And in here, I have, let me close this Maven window, not necessary. Let's just minimize that. So you can see here that I have a traditional Spring Boot application annotated with Spring Boot application. It has its main method, and there's nothing else in there, I guess, other than the empty properties file. All right, so the next thing I'm going to do, also, let me show you the POM in here so you can see what the Maven dependencies that were brought in here. You can see that I'm using 3.1.10 Spring Boot version. And we have the basic dependencies that you can get to build a simple web app. So in here, I have the Spring Boot starter. The project, it's a Java 17 project. I have the dev tools, Lombok, love it or hate it. I still like Lombok, facilitates a lot of the CRUD methods that you normally write. And I have the Spring Boot starter tests, even though I'm not writing any JUnit tests for this yet. So then the next step is that we are going to load a Docker Compose. So the Docker Compose that I loaded right here, you can see the Docker Compose. This, it's going to allow you to pull Redis Stack, the Edge version of it, and create a container called Sakula Redis. You can see that I'm actually persisting the data. So notice that I have volumes, and I mapped it to the Redis data folder, which is up here. So I'm persisting my Redis database. This is something that still people are surprised that, oh, I thought Redis was only memory. No, you can basically persist your data, and it does it like most NoSQL databases would do. It takes a snapshot, and then it persists those snapshots to disk. When you restart, you basically have a main binary dump of the database, and then the snapshots that weren't applied before are applied, and that becomes your new memory image. So just like any other database from an operational developer point of view. So if you want to run your Docker container, you can run it right from within IntelliJ, or you can basically go to the command line and type Docker Compose up. Let me show you that I have already my Docker container running in preparation for this. So notice that I have my Sakula Redis container here, and it's running on the traditional Redis ports 6379, 6379. And I had, my SQL running too, so I can show you some comparisons there, running also on the traditional MySQL ports 3306. And I also have, to visualize the data in Redis, I have Redis Insight. And noticing here that I have a database created locally to, or a configuration for a local database. It shows you here the things that are loaded on that database. So I have Included in Redis Stack, you have Redis Search, Redis JSON, Redis Graph, Redis Time Series, and Redis Blue. So in here, I'm going to go into the data, and you can see that in Redis Insight, this first view where it has the key, the browser, you can see the keys that are in the system. You see a initial number of keys. Notice that I have 47,000 keys. That's the totality of the Sakila database imported. So if we click on one, notice that here we have, for example, film text, some of those values, some of those entities that we saw in that ERD diagram. There's a rental, there's payment. So let's take a look at the rental, which is one of the entities that we're going to be working with the most. So here you can see on the right, there is the view for the specific key. So I have a JSON key represented by that key value. So Sakila.rental and then some number. And keys in Redis are basically up to you, up to the developer and up to the framework developer. So in the case of the Sakila application, I kept the keys to match the name of the table, the Sakila prefix as the database prefix, and then whatever primary key the data originally had. So typically in Redis, I like to work with ULIDs or UIDs instead of things like integers, but the Sakila database uses integers in most places. So you can see here that I have a prefix to my keys for a specific table in the database, but the value of the key is an integer. And the value of the key and the value of the ID in Java are related. The ID in Java would be, for example, for this rental field would be the integer 14,236, while the key is this full string. So you can see that there's a relationship between a primary key or the primary ID of an entity and the key in Redis, but they're not the same. They could be the same, but they're not the same in this case. And in most cases, they're not the same. So you can see here that we have a very simple JSON document, and we have some values in here. The dates in Redis Spring are stored as milliseconds from the epoch. That allows us to basically treat them as numerics and do things like search range searches and things like that. And notice in here that we also have references to other objects. So for example, other entities, there's an inventory field in our Sakila rental that points to an inventory entity. And there's a customer, a staff, and a film. All right, so now let's go back to the code. All right, let me close the Docker Compose. We are done with that. The first thing you're going to have to do is bring some of the dependencies to basically work with Redis on Spring. So I just added here, if you see under the tree view, there is a data folder, and in there is my Sakila Redis JSON database though. So you'll be using this to get started with this database. Let me see if I can, let me open it in a Finder, and I'll just open it with something that can handle large volumes of text. So I'll use Sublime for that. But in here, you can see that the JSON file, it's a pretty chunky JSON file, as you can see by the 30,000 foot view on the right hand side. So that is all the data for the database, pretty extensive chunk of data. And to load it, you basically use the Riot loading tool. It's a single one command. Basically, you point the Riot import to the file, and before you know it, it takes less than 5 seconds for all the data to be in Redis. All right, so now let me do what I said I was going to do. It's basically bring the Redis on Spring dependency. So here you have our POM, and I just added here in this chunk the dependency. So right now I'm using a snapshot version because I was fixing some things last night. Oh yeah, by the way, I am one of the main maintainers for the library. So when something breaks, I'm the first one to find about it because I build a lot of things on it. So here is the com.redis.om group ID. The artifact, it's Redis on Spring, and it's the 0.85 version. So 0.84 proper release is out there for you to use, which should basically give you exactly the same functionality that I have here today. Now, if we go back to the application, we can start making some changes in here. So first, I'm going to add the annotation that enables Redis own repositories to be detectable and be processed on application startup. So in here, I've added the enable Redis document repositories. So that it's going to scan your Spring application for repositories that are attached to document annotated entities. And then I'm going to now add a model to our application. So here I'm going to, you can see that now I have a entities folder or entity Java package, and I have an actor class. So the actor class, right now, it's a plain POJO, it's a plain Java class. It's annotated with the Lombok data, so I can basically get getters and setters and some constructors. But it's just that, a plain Java class. So let's turn that into a Redis entity. So to do that, we're going to have to add the data annotation. So there is the document annotation. So notice that I have my document annotation, and inside of the annotation value, I'm saying sakila.actor. That is the prefix for the keys that will be used in Redis. So whatever the actor ID happens to be would be attached to the sakila.actor prefix, or we prefix with this string value, and that would be the key in Redis. All right, so that is how easy it is to turn a plain Java object into a Redis entity in Spring. And now we need to do some of the proper things that we need for an entity. So in this case, I'm going to annotate the actor ID with the ID annotation. So this is the Spring Framework data annotation from the data annotation package. So this is the same one that you use for JPA and for other Spring data projects. But also, I'm going to add a repository now to be able to manipulate this actor. So let me I added a repositories package under entities. And in there, I have an actor repository. And notice that repository, it's a very simple class, interface that extends the Redis document repository interface. And that is part of Redis on Spring. So document repository goes hand in hand with document annotated annotations. So notice actor, it's a document annotated class. And then in here, we have a repository that extends document repository with actor as the entity and integer as the key type. So the second parameter on this repository would be whatever data type your primary key or your ID annotated field happens to be. So it happens to be an integer here. And in our repository, it's also an integer. All right. So now let's go back to the application. And in here, I'm going to add a logger. So here's a logger so we can basically visualize some of the output that's going to happen in here. We're not going to create a full-blown web app or try to use a controller to get to the data. We'll just do it all in the application so we can focus on the entity mapping and searching capabilities of Redis. So we have a logger added in there, and then I'm going to add a command line runner. So if you're not familiar with Spring Boot command line runners, it's a method that's annotated. It's a bean annotated method that basically returns a command line runner. And when the application starts, Spring will detect the command line runner methods and run them. So in here, we have a command line runner that takes this lambda argument. And inside of that, we're using the logger that we just added to basically say, welcome to the Sakulla Redis demo. So we should be able to run that. And you can see that the application ran here below. And here is our welcome to the Sakulla Redis demo message. All right, so now that we are cooking with fire, let's move and start seeing things happening in here. So the first thing I'm going to do now is I'm going to bring in the actor repository so I can manipulate actor objects in this command line runner. So we're going to inject it into the command line runner. So notice in here, I have the actor repository as a parameter to that run method. And I called it actor repository appropriately. And our first query ever is going to be a count. So notice in here that I'm basically printing the number of actors in the database. And to do that, I'm basically using the actor repository count method. So before we do that, let me go to Redis Insight. And Redis Insight has this really cool facility to basically profile what's happening in Redis. So it also has a command line interface. So you can see in here, I can, for example, inspect the keys in the system. The keys command, again, very dangerous in production. This is a developer-only command because in production, Redis can have billions of keys. In here, I just have a few tens of thousands. So the keys command, it's actually pretty fast. You can see that I have close to 50,000 keys, and my keys command basically returns all of them quickly. But if this was billions, I would be locking the Redis instance and preventing others from getting work done. So let me start the profiler right here. And you can see that whatever I do against Redis, you're going to see in the profiler. So I basically did the keys command, and you can see it echo here. So now let's go and run our project again, and we'll see what happens. So here's the actor repository count, and let's just run that again. And you can see now that we have a message that says there are 200 actors. So we go back to Redis Insight, and you can see now that there was an fdcreate command. So the fdcreate will create the search index. And notice that we created a search index against the call actor IDX. So that's the name I picked for the indexes, whatever the class is, plus IDX. It's an index on a JSON data type. The prefix for the keys to find it's Sakulla actor. Let me pause this so it starts, stop scrolling. It's Sakulla actor. The language is English by default. The schema, it's basically where the definition of the fields are index goes. So in here we have the actor ID. In the JSON name for that field, it's $.actor ID. And I alias that as actor ID automatically. And notice that that's indexed as a numeric. We have an integer ID. So a numeric schema field type it's used. And we made it sortable because we want to do Spring needs to basically do range queries and things of that sort on a primary ID to make it efficient. After the index was created, the indexing happened in the blink of an eye. Then we can actually use search commands. And our count method in the repository was invoking the fd search command. So we have the fd search command against that index that was created, counting everything in this limit 00. Basically, it's the way to do a count query efficiently in Redis search. All right. So that's just the beginning. All right, let's see what we have cooking next. So now on the actor, I'm going to annotate the last name as searchable. So notice in here that now the last name is annotated as searchable. Okay. And one of the things I'm going to have to do, of course, is that I'm going to have to drop that index because I want to recreate the index. So Redis own Spring by default would not destroy an index that has been created. That would be probably traumatic in production to any operator. So the creation, it's if an index doesn't exist, it's created. But if it's already there, we skip the creation process because we don't want to damage any data potentially. So you have to manually go and drop an index if you want to enhance that index. And in development, it's typically that you will basically flush your whole development database and recreate those. So in here, I'm going to do the command to drop that actor index. That way, when we run it again, it will recreate the index now with the new values that we have. So in this case, I added the searchable annotation to the last name. And now we're going to do something to the repository too. So in the repository, I added a custom finder method. So the nice thing about Spring repositories is that you can create a fluid definition of, or a method name based query by simply knowing the patterns to follow in Spring Data. So in here, I want to get a list of actors, and I want to find those actors by their last name. And I'm passing in a string as the last name, and then Redis on Spring and Spring Data will determine how to assemble the proper query to retrieve that data. So now let's go back to the application and let's make some changes in here so we can see that new query in action. So in here now, we're going to call our new query, and I put the equivalent SQL query that would be generated. So the equivalent query would be a select star from actor where the last name equals the generous. All the names in this database are fake data auto-generated. So obviously I have to go and look at the data to find out what names I could actually find there. So I'm here creating a list of actors, just a var that is going to hold the actors. And then I'm invoking the Redis repository, the actor repository, find actors by last name, passing that string the generous. And then I'm going to basically loop through those actors found and print them to the console. So let's go ahead and run that. And hopefully I haven't broken anything. No, that's great. The demo got, so notice this. Everything's so fast right now since we're doing it on the startup of the application didn't have really time to warm up. So it's things that there's no actors with that last name, but that is because we dropped the index. So the index needs a little bit of time to basically re-index all the values of the database. So if I run it again, you should be able to see the values there. So typically, you would not do this on a command line runner, but it's actually very convenient for demo purposes. So now you can see here that the actors whose last name is generous are Gina, Nick, and Jody with the IDs 107, 166, and 41. Also, to validate that, let me grab that SQL query, and we can hit the equivalent MySQL database that I have sitting on my machine too, where the data came from originally. So here's that same query, and we run that, and you can see that we have Jody, Gina, and Nick in the database. Same values in here. All right. Oh, and let's actually go to Redis Insight and take a quick look to see what the data looked like on that query. So here's that FD search query. And notice that the search query here, it's again the same index, but this time we have the at last name string. So the query string is at last name colon the generous. So for a searchable annotated field, this is the syntax to basically do the search. And notice that we're basically doing a limit of 10,000 in here, elements. So the framework, Redis on Spring, will figure out all the complexity of the search query for you, and all you have to do is do your typical Java query creation. All right. So now let me go back to the ID. So in here, to the actor repository, we're going to add some more values. So in here, I have an actors by last name starting with. So this is going to give you a view into some of the things you can do with more complex queries. So now we have our new query method in the repository. Let's go back to the application and make some changes in here too. So we do our quick testing right here in the application main file. So here is the equivalent SQL query. It's going to be a select where the first name is a value and the last name is another value. And notice in here, we invoked our query again using the repository. And this will return, this will return an optional of actor. Since we're looking for one specific actor, it could be found or it could not be found. So we use the Java optional as the response type. And in here, we check if it's present. And if we found that person to be accurate, which we know it's in the database, we're going to print the value of that person. And since we, let me see, so we index a new field. So we need to drop that index again. So let me quickly go here and drop that index. And now I'm going to run this. And again, we might have our indexing issue. Yeah, we didn't find it because we were in the process of indexing in Java. It's actually too fast nowadays. So now notice that I ran the code again and I have it found the user Debbie Ackroyd, which her ID is 182. And once again, we can confirm that in the MySQL side. Let's add another little tab in here. Boom. And there is Debbie Ackroyd 182 ID. All right. So now let's move on and do some more fun things. So now the next step is I'm going to add all the entities that are in the database. So now that we know how one works, here are all the other entities. Now I want to take a quick look at, let's see, for example, address. So here is the address entity. Notice again, we have document annotation. We have Sakila address as the prefix for the keys. We have a primary ID, an ID annotated field of type integer for this specific schema. We have a reference annotation. So this is a Spring Data reference annotation. And this allows you to have a reference to an external JSON object in Redis. So for example, in here, we're pointing, notice that we have an object of type city, but in the data in JSON, we're going to store the city ID instead. And the reference annotation, it's a new addition to Redis on Spring. So we're still kind of working out the kinks, but the basic functionality is there right now. All right, so we have the remaining entities and repositories. So all the other repositories have been added in here. Most of them, you can just basically have an empty repository, just use the built-in methods from document repository extends the key value repository, which extends paging and sorting repository, which extends CRUD repository. So you get all those methods added to your arsenal for free. All right, so we have that. Now let's test some other queries. So going back to the application, now I added a query here where we do a search using a set. So in this case, I'm basically looking for a list of countries using the country repository. Notice that up above in my command line runner, now I have injected the country repository into my command line runner. And this method takes a set of countries to be found. And if you look at the country repository, here's the signature for the method. It returns a list of countries. It's called find countries by country in. So when you do in and pass a set, we're going to return any countries where the country value it's in that country field of the country object. That's a lot of countries for. So here, let me show you. It just happens that in the schema Sakila, the country entity also has the name of the country as country. I would have called it name So you could say country name, but that's why we have this richness of the word country all over the place in there. So we have this in place. Let's go ahead and run it. And here we found the countries by their value name. And you can see that Afghanistan is number 1 in the database, 23 is China, and 12 is Bangladesh. All right. So that's a slightly more complex method. Now, we also have all the built-in methods, like I mentioned. So here, let's do something with the find by ID. So if you use Spring Data, you use find by ID before. So in this case, I'm going to, let's just run this, see if it works. I don't know if I need to delete any repos. Let's see. Yeah, so in here, I looked for the rental record with ID number 1, and I found it. And then from that rental record, remember those reference fields? I used that to get to the customer of the rental, that the customer that rented that DVD. And I grabbed their first name and last name. And I also grabbed the name of the film that they rented and the rental date. So you can see here on the output that we have the customer Charlotte Hunter rented Blanket Beverly. Those are also generated names. So there's a lot of funny names in this database. On May 24th of 2005. That should give you an idea of the age of this database. And I believe the data has been refreshed several times since it was created. So this database, it potentially could be older than most of the audience. All right, so now let me do the next demo. So now we're going to test joining tables. So I'm going to go in here, and we're going to need a couple of repositories for this. So there's the film category and film actor repositories. So those are 2 repositories that are connecting their join table entities. And down below, now we have a test for those join tables. And again, what we're doing in here is just making sure that we can get to those objects that live inside that are referenced in the values. So in here, you can see that I retrieve basically the values from the film category and film actor tables by those specific IDs. So one of the things I did in this specific implementation is that for those join tables, the ID happens to be a string, and it's the concatenation of the 2 primary keys of the values used. So that gives me the ability to do some interesting things with it. So let me show you this find all by ID, the film categories object. So let me go show you the film categories object. Notice that the ID, it's a string, and then you have the film and category. So the code that generated this, the data, took the film and the category IDs and concatenated them and put them in film category ID as a primary key. So the difference is in SQL, you can have this tables with no primary IDs. In our case, we have everything has a primary ID. So we generated one that made sense. All right, so let's move on. We got just a couple of examples left in here. So there is another find by ID. Let me run that one in here. It's just to make sure that we can retrieve a film and its length, because we're going to be seeing that value. So notice in here, the film with ID 77, it's Burke's Perdition, and it's a 61-minute long film. And now let's do something a little more interesting. So in here, we're going to do a range query. In this range query, it's finding all the films by the length of the film, when it's between 60 and 62 minutes. So a very narrow range of films we want to find in here. Since this is all randomly generated data, that was a range that would bring me a manageable number of films to show on screen. So, and again, if we want to look at the definition of that repository method, very simple in here. Notice that I have a min and a max. And the keyword here is the between. So if you find the keyword between in one of the repository methods, the framework will know that this is a range numeric query. So let's go ahead and run that. And what we did here is just count how many. So notice in here that there are 24 films between 60 and 62 minutes long. All right. Okay, so now I'm going to introduce you a different way to query the database. So the Spring Data repository methods are great. They're basically the right amount of magic to get something working. But when a query gets much more complex, the complexity of the method name can grow exponentially. So there's a point where they basically cease to be useful. So for that specific case, I created something called an entity stream, which is an API that allows you to basically query fluidly, and it feels like the Java Streams API. So here, let me show you, we're going to inject an object into our command line runner. So notice I injected the entity stream object. So this is from Redis own Spring. And below, I added an example, a super simple example of how to use it. So the first example of an entity stream, notice in here that I'm creating a search stream for country and for the class country. And it's an entity stream of country. And by doing that, that is basically the equivalent of the select star from the country table or from the country collection. So let's go ahead and run that. You can see, so this should give us a count of all countries. So notice that there's 109 countries. So great, but how can you do the more complex things that entity stream it's meant to satisfy? So in here, I'm going to now do another example where I introduce a concept called the meta model. And in here, notice that I have, again, the same definition, but this time the return value is going to be called, it's going to be named some countries. And in some countries, I'm creating an entity stream of country, and I'm going to filter that stream by using this meta model object provides basically constants that allow you to do specific operations against the index and non-index fields of that country class. So the country class has, remember that the country name, it's in the field country. So the country dollar meta model object provides a country constant that has operators like in. So I can say, find the countries in Canada, Israel, and Sweden, and then collect that to a list, just like you would do in any regular Java stream operation. So I'm going to run that. And you can see here that I've found the entities for Canada, Israel, and Sweden. They have the IDs 20, 48, and 90. If we go to Redis Insight, let me restart the profiler. Okay, I reset it. Let me restart the profiler in here, and I'll run it one more time so we can see that value. Boom, running. And you can see now my FT search command, which is, the first one is the count. The last one in here, let me pause this again. It's FT search against our index. And notice in here, we have the country, which is a tag type field. And we're passing the value, what is it, a tag or is it an index? Let's see. Country, 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 it's index. So that's a tag style search. And that's why we have the curly brackets rather than the value that we use for the full text search. So in here, notice that we're passing the strings Canada or Israel or Sweden to this element of the query. And again, all that you get from this fluid interface. So let me clear this and restart the profiler. Okay, I got just about one example left before we close. So the entity stream allows you to do things like, for example, here is that same list of countries, but sorted. So I repeated the same query, but notice in here, I added the sorted that takes values from the meta model object in here. So I can basically, and again, these are generated objects. So country, dollar, it's a generated object by the framework. So when you build your application, it would be magically there for you. So in here, I sort my country and I sort it descending order. And again, I collect to list. And if I run that, I should have my list sorted correctly. So notice I have Sweden, Israel, and Canada in that reverse order. Also, I can do things like this. So here's another entity stream query against Redis. I'm going to filter by the country that starts with the word with the letters P and A. And again, I'm going to sort it and I'm going to map to a single value. So you can also, rather than get the whole object back out, if you have very large JSON objects, you can say, I only want this specific entity or this field from the JSON. So in here, I use the map method to use the meta model to indicate that I want only the country string value. So let's go ahead and run that. And you can see here that I have the two countries that start with PA in this database are Pakistan and Paraguay. All right. And again, you can do all kinds of things. Here's an example of doing a count. So I'm filtering, I'm doing again that same method that we did before, but rather than writing a custom finder in your repository, you can say, I want to find, I want to do an entity stream of film. I want to filter by the length of the film being between 60 and 62 minutes. And then I want to count that. So you can do basically aggregations on the fly here. So if I run that, I should get again the number 24, which is what we got before from the custom repository method. And okay, now I'm really not lying. This is the last example. So the last example, it's an aggregation. And it's a simple aggregation. I didn't want to get too involved in here because I know we are time is precious in here, but this is the last example. And this shows the power of aggregations in Redis Home Spring and Redis in general. So in here, I have another entity stream with the rental class. I'm loading a specific fields from that rental class. I'm filtering for the ones that don't have a return date. So notice that this is an aggregation to find all overdue rentals. So all the rentals that should have been returned by customers, but they haven't been returned. And then I'm going to apply this formula here that you can pass as a free-form string that says, I want to add the rental date for times the rental duration, which is in days. I'm calculating, I'm turning them into the same units in here. And I'm going to put that in a variable called overdue date. That's going to be part of my aggregation pipeline. Then I'm going to filter for the ones where the overdue date, it's less than the current date. And then I'm going to sort them. I'm going to sort the whole thing by the rental date. I'm going to limit just the top 5 values. And then I'm going to grab all the values that were created in the pipeline. So notice in here that there's 4 values. It would be 1, the key, underscore key, the rental ID, and then the overdue date and the rental date. And I'm grabbing those as strings because I didn't want to do the transformation on the fly, but you can change the data types to date, and the framework will basically parse those for you. So here, let's run that last method in here. And you can see here that the 5 top overdue DVDs are this users. So the user, Dwayne Olvera, and we got the phone number in here. So imagine somebody at the store wants to call that user and say, hey, where's my DVD? You rented it in 1985 and it should be back by now. There's only so many times somebody can watch Footloose. I believe that's 86. And here are the title of the DVD that was rented out. All right, so let me go back to the slides and close this. All right, so I can skip some of this. Let me move to where I wanted to skip in here. I'll show you one slide in here for the aggregation pipeline. So this is what the Redis search aggregation pipeline looks like. So you have basically a way to create very complex aggregations if needed. And there's a few more slides about Redis on Spring, which you can see when I share the PDF. And I want to close by saying that if you want to learn more about Redis and all the capabilities that are waiting for you to use in Redis, come to Redis University. We run an education program there where you can basically get certification, and we have courses about different use cases, different data types in Redis. So it's well worth the time. And thank you very much. I'm very happy to be here, and I will be checking the chat now and see what's going on in here. All right, so we have a few questions in the chat. Number one, it's from Mike asking, what's the difference between hash and JSON? So the difference is that hash gives you a lot of flexibility, but again, a hash, every value in the hash is just a string. And the framework will have to, if it's something more complex than just a string, it has to serialize it into something that can be put into that string. So for example, if a hash has a sub-value that you want it to be an array in your Java code, then we have to turn that into a string representation of an array and then parse it back out to put it back into your Java string. Well, for example, in JSON, JSON has a native string, native array. So we will store the value as a native array, and then the extraction in parsing will typically be faster and much more flexible too. So the Doug was asking if the session, is the session recorded? I believe the session will be recorded. We have a sister framework to Redis on Spring called redishome.net. And there's also a Node.js framework. So we have those. The question was whether we have similar examples in C# or JavaScript. And yes, there are. There's a Redis node and a redishome.net. And then finally, Mike is asking for join type queries, do you have to create a join entity for every possible join that you will require, which consequently will persist the join results? So there's really no join queries. The best you can do in a NoSQL database like Redis is to basically create a scheme like I did in here to having a join entities, and then you get the values by ID, and then the framework refreshes the results for those IDs with the full object at runtime. So yeah, there's multiple calls to Redis to basically rehydrate those reference objects, but Redis does it in pipeline mode, and Redis again is so fast that it even beats the joining on the relational database, at least locally on my machine. But Redis typically beats pretty much everything on my machine locally on any server out there. So that's kind of my answer for that. Well, thank you very much. It was a pleasure being here with you. It's very early in the morning, so I'm going back to bed because it's just 6 a.m. in here. But yeah, it was a pleasure presenting this material to you. And please stop by Redis.io and check out what we have to offer. Thank you. Goodbye.